In this video, I will explain how to calculate the yield to maturity of a bond. So let's start with the definition. The yield to maturity, or often abbreviated YTM, is a bond's overall rate of return when purchased at market price and held until maturity. Now, the formula to calculate the yield to maturity is this formula right here. We say C plus F minus P divided by N all over F plus P divided by 2. Now, in this formula, C is the coupon or the total interest paid each year. F is the face value of the bond or the issue price of the bond. P is the purchase price, so how much you actually pay for the bond. And N is the number of years to maturity. Now, it's worth noting that this is an approximate formula. So this formula will give you an approximate value of the yield to maturity. And what we're going to find is that it does a very good job of getting close to the exact yield to maturity. Now, the formula to calculate the exact yield to maturity I'll mention at the end of this video, but it's very difficult to do by hand. So we typically use software like Excel or a financial calculator or some other financial software to actually calculate the exact yield to maturity. And one other thing worth noting is that this formula assumes that coupon payments are made semi-annually, which is typical of most bonds that you can buy. So with that in mind, let's go ahead and check out an example of how to use this formula. This example says, suppose you purchase a $1,000 face value bond for $980 with 20 years to maturity and has a coupon rate of 4% paid semi-annually. What yield will you realize if you hold the bond until maturity? So in other words, what is the yield to maturity? So to calculate that, let's use the formula that we just defined. We'll say YTM, the yield to maturity, is C. Now C is the coupon, so that's the total interest paid in a year. So we're told that the coupon rate is 4%. So 4% of $1,000 is $40. And yes, we are getting paid semi-annually, but in this formula, the C is just the total interest that we're getting paid in a year. So in this case, we're going to use $40 for C. So we'll say $40 plus F minus P. So F is the face value. We're told that the bond has a $1,000 face value. So let's write that, $1,000. Minus P is the purchase price. So we're told that we're going to purchase this for $980. And then we're dividing that by N, which is the years to maturity, which we're told is 20 years to maturity. So divided by 20. And then all of that is divided by F plus P. So the face value plus the purchase price. So let's write that. So we have $1,000 plus $980 divided by 2. Now, if we simplify this a little bit, here's what we get. So in the numerator of this fraction, we get $40 plus $1, and in the denominator, we get $999. So if we simplify that a little more, we get $41 divided by $990, and that turns out to be 0.04141. Now, as a percentage, if we move the decimal place twice to the right, that would be equal to 4.141%. So this is our yield to maturity for this bond, or in other words, it's the overall rate of return that we would get when we purchase this for $980 if we held it for the full 20 years to maturity. Now, the exact formula to find the yield to maturity is this formula right here. We say P, the purchase price, so in this case, our purchase price would be $980, is equal to the sum of K equals 1 all the way to N, where K is the periodic payment. So remember we said in this bond we're getting paid semi-annually. So the total N, the total payments, would be 20 years times 2, which would be 40. So we're taking the sum of each period, we're taking the coupon payment. So again, we said we're getting $40 annually for this bond, and it's getting paid semi-annually. So every 6 months we're getting $20. So the coupon payment would be $20 divided by 1 plus the yield to maturity, which we don't know, that's what we would be solving for, divided by M, which is the number of payments made annually, which in this case would be 2, raised to the power of K, where again, K is the period. So it's a very complex formula, and it turns out that you have to iteratively guess and check for the yield to maturity if you were to do it by hand. So it's very difficult to solve for yield to maturity by hand using this formula. So that's why if you do need to calculate the exact yield to maturity, you typically have to use some type of financial software. And it turns out that if you enter the values for the face value of the bond, the issue price, the years to maturity, and the coupon rate, if you entered all that information into financial software or calculator, the exact formula comes out to 4.148%. So we can see that our approximate formula does a very good job of approximating what the yield to maturity is.